Hello everyone, welcome to Science and Tech series with Dr. Vivek. Rana. Topic for today's discussion is from nuclear energy. Kakrapar Atomic Power Station has attained criticality. So we will dwell on what is the significance of this development because it is being touted as a significant nuclear milestone. Prime Minister Modi has already hailed it as a trailblazer for future developments as well as a shining example of Make in India. So it is not that it's the first ever indigenous pressurized heavy water reactor, nor it is the first for Gujarat. So why is this nuclear reactor gaining a lot of attention? So let's decode first of all what term criticality means, because this is what the science is about. First of all, you have to understand whenever a nuclear reaction which is being carried out is being able to be executed through a controlled condition in a sustainable way, then it is said to have attained criticality. So in simple terms, we can say when a reactor is ready for commercial power generation, then this term comes into picture. So we all know the process behind this is nuclear fission, in which simple terms we can say this is fragmentation or splitting of a large nuclei when hit by a neutron. It breaks down into small nuclei, releasing enormous amount of heat energy. This heat energy is used to generate steam, which is eventually used to turn the turbines which generate the electricity. So what is the main thing about Kakrapar is that it's the third unit which is there at the Gujarat. To be more precise, it is in Surat district, because once a nuclear plant is in news, you should go into little bit into the specifics as well. And it's an indigenous pressurized heavy water reactor. Pressurized heavy water reactors, they represent the first stage of India's ambitious three-stage nuclear program. And out of the 22 operational reactors, majority of them are pressurized heavy water reactor. They use uranium as fuel, and heavy water functions as moderator as well as coolant. Comparatively, it's economical to generate electricity through this PHWR reactor compared to the FBR, fast breeder reactor, which represent the second stage, which use plutonium as fuel and liquid sodium as the coolant. So here the major thing is that in Kakrapar there has been upscale of energy generation. Previous heavy water reactors have been more or less around 220 megawatts, and the biggest ever indigenous pressurized heavy water reactor is at Tarapur, which happened to be the first pressurized heavy water reactor as well, which could generate up to 540 megawatt. So the current one, which is you are following in the news, is capable of generating 700 megawatt of energy capacity. So overall, from Indian energy matrix, it's a significant development. It not only is the example of indigenization of pressurized heavy water technology, which we had already long back, but it is the upscaling of the reaction, because this will pave, or you can say pave the groundwork for the next milestone, because India in future is aiming for 900 megawatt nuclear reactors, and currently the other construction reactors, and there is two going on in Rawatbhatta and there is another one at Kakrapar. They are to be of 700 megawatt. So the initial success which we have got at Kakrapar sets the stage that we can attain criticality in the upcoming nuclear reactors as well. So it's yes, it can be touted as a step towards Atmanirbhar Bharat, because India is moving towards cleaner energy, and to have a clean energy source, even if it's through nuclear, there is no harm in going about it. And because India's current energy share of nuclear energy is just 2.3%, which is quite less considering that we had an early start in nuclear energy. But since we didn't have the requisite fuel, and we are still working on the third stage thorium cycle reactors, we have not created reliance on nuclear energy as of now. But yes, our vision is to upscale, and by 2031 we are aiming for more higher scale targets. So in this topic, you just have to brush up what nuclear fission and fusion is, and you should also go through the list of operational reactors because they are in news. I will just brief you up for once again. This is the 23rd reactor which has been now in operational stage. The earlier 22, if we break down, 6 are at Rawatbhatta, Rajasthan. Then we have 4 at Kaiga, Karnataka, another 4 are functioning at Tarapur, Maharashtra, and 2 each at Narora, Uttar Pradesh, 2 in Kakrapar, Gujarat, and 2 in Kundankulam and Kalpakkam, which happen to be in Tamil Nadu. So make sure you don't brush up this one. And we have other upcoming plants as well at Chaya Mithi Vidhi in Gujarat, there is Kovda in Andhra Pradesh, we have Mahi Banswara in Rajasthan, and also Jaitapur in Maharashtra, and we also have Chutka at Madhya Pradesh. So make sure you also go through the list of under construction, and Fatyabad is going in Haryana is going to be one of the biggest reactor when it becomes operational. So you will come across these terms or sooner or late about criticality, what is fission, what are the basic components, what is the role of moderator, what are control rods. So which we have already covered in lecture, so I am not repeating them. But in case anyone has any doubts, you could just jot them down in comment section. I will try to answer them. So this is what the development is. Once again, you don't have to carry it away with statements like it's the first indigenous reactor. It's not. We already have multiple indigenous. Yes, it's the 23rd reactor and it's the biggest in terms of energy generation for the time being, 700 megawatt. Because in newspaper, a lot of students might have got confused that hearing that it's the first indigenous pressurized heavy water reactor. Is it some new technology? No, it's the conventional technology which represents the stage 1 of nuclear energy program. So this is it for now. I hope this session was useful and help you in revision of the basic themes of nuclear energy. We'll be back soon with another science and tech or environment lecture shortly. Thank you very much. Keep working hard.